All right, guys, here's our last section in chapter 5, and we're going to look at taking data and trying to create our own curves for them. We're going to do everything as sine curves because sine curves are nice, because if you'll remember, they start and end at the same place, okay? One peak, one valley, whereas a cosine starts up, bottoms out, and then comes back. So we can get a cosine curve to a sine curve by just shifting this guy and extending it, but we're just going to look at sine curve because it gives us 3 zeros, okay? So we're going to be able to do two things. I should be able to give you characteristics, and you should be able to tell me the equation for it. And we're going to look at data, temperature data, some things with farming, stuff like that, and be able to create curves from them and help us out with our calculators. Okay? So first thing is, if I give you something like this, you got to be able to come up with the actual equation. So instead of me giving you the equation, you got to produce a picture. I'm giving you information, you got to go backwards. Okay? So if you remember, we start here, everything's going to be in a sine. We get that b factored out, and it looks like this. Okay? So see if you can take these three pieces of information and plug them into those guys. So it wouldn't hurt to pause it here and try it for a few minutes. Okay? If they tell you the amplitude is 2, well, it's a dead giveaway. That's going to be your A value. Okay, so it's going to be twice as tall. So we got that guy taken care of. They tell you the period is pi. Okay, and this is where it gets a little bit goofy. All right? Anytime you're dealing with one of these period questions, we got to come back to this equation right here. Instead of being given a b value and you guys have to go find the period, I'm instead giving you the period, we got to go find the b value. So if they're telling you the period's pi, plug that in for the p. Remember, this is over 1. These guys can then trade spots because they're on the diagonal. So we can say b equals 2 period over pi, and b equals 2. So we have that. Phase shift of -1/2. Okay, so this guy doesn't have a shift of pi or anything in there like that. Okay, it's a shift of 1/2. So this guy would actually be a little bit ugly to get on graph paper. Okay, if we're shifting at -1/2, our equation is always x minus c, just like it's been for quadratics, just like it's been for square roots. Here, it's the opposite piece in there. So when we go plug this in, that minus minus becomes one big plus sign. Okay? So when you look at your final product here, you should be able to look at this and say, okay, it's twice as tall. The b is a 2, so I can go plug that guy in right here, figure out my period is pi, and I look at this, and I'm going to say it's going to be opposite. So I'm going to say left 1/2, which gives me the phase shift of -1/2, and there's no d value. So I could say, you know, it moves up by 6 units, and you could go throw a +6 on there as well. Okay, so it's just kind of going backwards from there. So this would be your finished product. Just like creating your own quadratics, you can look at your final thing and figure out if it does everything you wanted it to. All right, so we're not gonna graph that guy. We just wanted to go backwards. Okay, so there's half of it. The other half here is really kind of interesting. Okay, now if you guys don't have your books here, I'm going to throw the data in our calculators. So I would suggest doing that as well. So basically, this table on 430 gives average monthly temperatures for Denver for some year. Okay, so there's 12 months, and it gives an average monthly temperature for each of them. And you know, we can make predictions about what's going to happen with them. Okay, the nice thing when we're doing these is we can use our calculators to check we're doing these things in the right direction. Okay, so we're going to use some scatter plot stuff. So going to Stat, Edit, make sure you clear your lists out, and make sure you have list 1 and list 2. If you accidentally deleted a list, remember, go up there and say second insert, second list, and it'll come back for you. Okay, so here's how we're going to do it. Each of the months just going to be represented by a number, and those are our X values. Okay, over in L2, here are the temperatures again if you don't have your book at home with you. So January's 29.7, 33.4, 39.0, 48.2, 57.2, 66.9, 73.5, 71.4, 62.3, 51.4, 39.0, and 31. Okay, so what we can do, first thing, make sure your mode is in radians, because we're going to be using pies, not degrees. So make sure that's taken care of. Make sure your stat plot is on, and hit your zoom 9, and we can look at this. Okay. Now we're going to do signs for these because you can kind of see parts of a sine function here. It starts at 0, ends at 0. Okay, it comes up to a peak and it comes down. Okay, so signs are just going to be easier to work with. Okay, here's the data. If you look at figure 88, it puts it in for 2 years in a row. Okay, so for 2 years would basically just be 2 of these, so another curve would be stretched out here. Okay, we just care about 1 year because when we graph the function, it's going to take care of year after year after year, and since they're averages, they won't deviate too much. Okay, average temperature may change a degree or two, but that's not a lot over time. Okay, so we got to go back and we got to try and get all this information right here, okay, by hand. And our calculators are going to help us out. So first thing we got to do is get the amplitude. Okay, so if we think about what a sine curve looks like, something like this. Here's our max, here's our min. We said amplitude was always just this guy right here. Okay, so it's basically your max minus your min, and then we divide this guy by 2. Okay, so according to the data, our largest temperature was in July of 73.5 degrees. Our smallest temperature happened in January of 29.7. So this would be up at 73, this would be down at 29. We're going to find the difference between them and then cut it in half to get the actual amplitude. Okay, so we cut this guy in half and our amplitude comes out to 21.9. There's our A value. Okay, that guy was pretty easy. All right, now the book kind of takes you through these things step by step here. So what you can do is you can go in and you can now say, okay, I want to graph, what did we say, 21.9? 21.9 sine of x. Okay, now it's not going to show up all that great for us because we don't have a very good window. But as we modify this thing, more and more will show up for us.